We have so far known that materials are categorized into three classes depending on the band gaps. They are insulators, semiconductors, and metals. But semiconductors itself can be categorized into two classes. They are indirect and direct band gap semiconductors. So today our topic is direct and indirect band gap semiconductors. So welcome to Materials Horizons and see you after the intro. So basically the band gap is defined as the energy difference between the minima of conduction band and the maxima of valence band. So now if a surface of a material, suppose semiconductor, is irradiated with photon energy, then what would happen? The electrons in the valence band top will absorb that energy, and if that energy is more than the band gap, then that electron will transfer into the conduction band. If this transfer is only limited to the energy difference or associated with energy, then that is the direct band gap semiconductor. If the momentum of the electron is changed, then that is indirect band gap semiconductor. So for direct band gap semiconductor, the momentum of electron is not changed, it is just directly transferred from valence band to conduction band. But in the case of indirect band gap, electron is transferred from valence band to conduction band, where it is associated with energy as well as change of momentum. So if we show schematically the EK diagram of direct band gap semiconductor, we see the parabolic band here of conduction band and the valence band, and say here K is equal to 0, that is momentum. So the upper one is conduction band minima and it is valence band maxima. So if the surface is now irradiated with the energy h nu and h nu greater than the band gap, that is Eg, then electron on the top of the valence band will be transferred to the conduction band. In this case, del K equal to 0. So this is direct band gap semiconductor. There is no change of momentum of the electron. Next we will go where there is also a minima of conduction band and the maxima of valence band, but they don't situate at the same K value. Say this is K equal to 0, but it has the minima of conduction band has finite value of momentum. Now in this case also, if we irradiate with energy h nu, then the electron will be transferred to the minimum of conduction band, but there is a change of K or momentum, hence the del K not equal to 0, and this is called indirect band gap semiconductor. The concept of indirect and direct band gap is very much important for light emitting diode application. Direct band gap semiconductors is always preferred than that of indirect band gap semiconductors, because there the emission of light takes place without any losses, which occurs in the case of indirect band gap, and these losses are generally occurred in the form of heat energy that happens in the form of absorption or emission of phonon. Phonon is nothing but the quantum energy of vibration. Uh, these band gap semiconductors have also other kind of applications. We are not going into much details, and thank you for watching. See you in the next video.